Hi guys. Today I'm gonna be teaching you my first lesson in Java. Here you can see the lesson plan. Today I was hoping we could go over um, hello world, some basic types in Java, variables, if statements, booleans, loops, and then if we will have some time, if we have some times left, we will go over some maybe methods. I apologize if the picture is not clear or because my internet connection is kind of lagging. So but I still hope everything will be seen. So I can zoom into if it won't be if you can see. So yeah, the first thing we have to do is check our Java installation. So if we run our command prompt, I'm not going to be teaching you how to install Java because there's plenty of tutorials on the internet for every possible platform, Linux, Windows, Mac OS, everything. So if you just typing into Google how to install Java JDK, um, you'll be fine. So to test if your Java installation is working, you just have to type Java, and you'll see this output here. This means it's installed. If it says Java is not recognized as a bad script or external program, then you probably have to include it into your path. And you'll also need Java C for compiling our programs, and you also will probably see something like this. I'm going to be using a pretty simple a text editor called Notepad++. You can use anything you like, Sublime Text, Atom, anything you prefer. I'm not going to be using an IDE, an integrated development environment, because I think it's more useful to see how the code is compiled, to see the errors, and the IDE just makes it more confusing for a beginner to learn stuff and to understand how the program is really working. So without further ado, um, I will I will just show you how to make a small program in Java that prints "Hello World" to the screen. And so what every program needs in Java is a class. So we make a class by typing public class, let's say hello world, and we have to, let me just enable um, syntax highlighting like this. Yes, we have to type public class hello world, or hello world is the name of the class. It could be anything. It could be lesson 1, uh, hi Reddit, as long as it is with no spaces and letters. Numbers are okay too. So I said it will be hello world. Everything in Java has to be inside a class. Every method, every variable, everything. So this what every Java program needs. Then the other thing most programs need is a main method. We make a main method by typing public static void main, open parens, string, args, and curly brackets. What the main method is the entry point to our program. For example, when we will run our Hello World class, the code that starts here will start executing. So when we execute hello world, main method will be executed. So if we write here system.out.println hello world, everything inside of these two this will be put out to the screen. Inside everything inside this code. For now, you'll have to trust me, but you don't actually need to know what this is. And this is really confusing. So if I would start explaining this right now, you probably wouldn't understand, and it would make you really confused. So for now, let's just save our program. Hello world. And it's really important that your Java programs are saved with the same name as your class name. So here hello world has to be the same as here hello world. So if I would open this map like here, we can see if I type dir, we can see that hello world is right here. I compile my program using Java C, hello world.java. See, and if there are no errors, it doesn't output anything. It's like this. So if we type dir again, we see that we have a new file called hello world.class. This file is the bytecode that gets compiled from our program, and it's executed in the JVM, or the Java Virtual Machine, that runs on any platform. So if we type Java hello world, you see it executed our little program called hello world. So when we run our program, we don't use .java. We just type the name of our class. So Java hello world. So if I would type here 1, 2, 3 and compile it again, like this, and it would also output this. Yeah. So that's for our hello world program. If you have any questions, you can type them in the comments below on the site, I think. But I will be so I can answer them. This was for our hello world program. Now we can move on to some more Java related stuff. This will be kind of boring, but you at least need to understand some of it, so you can start making some small programs. But really, you don't have to worry about any of this, because it's really confusing for a beginner. So everything for now will be inside these two brackets. Then when we will move on onto classes and objects and method and things like that, you'll start understand what public, what static, and what void is. So if I and also you can make comments in Java if you make double slash and type this will print out hello world to the screen. And this is just something that you can write for yourself to know what the program is actually doing. There's another style of comments like this. These are multiple line comments. like this. Comments like this. So these are just basically for you to document what your code is doing. So when you will be looking to your program in about 2 days, that you know what the program is doing. So if I go forward to basic Java types, we have, I think, 7 or 8 basic Java types. These are byte, int, short, I'll just make ascending int, double, float, long, boolean, and I think that's it. Yeah, so these are all basic primitive Java types. These are all for numbers. In byte, you can store values in the range from -128 to 127. In for example, int is from minus, I'll just copy the number. Yeah, and int is from this range. So these are all real numbers, so no decimal point. Double and long also. Probably I should copy it here, like this. These are all numbers without decimal points, so whole numbers. Double and float can take decimal point. For example, double can be 12.3, 11.5, like this. But the difference between double and float is that you can only have one number behind the decimal point. You can't have like this in a float. You only can have this. And Boolean is a primitive type that can only hold 2 values, false or true, like this. This is important when we will evaluate if statements, while loops, and things like that. So these are the basic, and I also forgot one basic type. It's called char, and char can hold anything. Basically, it's a character. It will hold this, anything, any single character that you can find on the keyboard, like this. So, and for example, if I'll just copy this here. This isn't actually code. This is just so I can type it out. And so, for example, we have also a string, but string is not a primitive type. It's basically a class that it's a class, yes, that stores an array of characters. For example, string, for example, hello world, inside quotes is basically just is the same as an array or as a sequence of H, E, L, L, and so forward to D. It's basically just that. It takes a sequence of characters and it turns them into one string. So for example, how to define variables. What a variable is just a way for us to hold our data throughout our program. For example, we can write string hello world is hello world. And what this will do, it will write a comment it will assign string hello world to our variable hello world, like this. So in Java, this is how you define variables. You first have to make write the type of the variable. Then comes the name of variable, and then an equals sign. This means this is an assignment operator. It means that you will assign a value to this variable, like this. So, and you can do, and now we can do this. We can substitute this string with our variable, like this. And just to see that it really works, we compile again and we run our program. And you see it works. Because when the print line function saw the hello world variable, it looked for it, and basically it looked what was assigned to it, and printed that out to the screen. Yeah, so that's basically it for variables. And you can also make, for example, int year, for example, now is 2015, and the year and the variable year will hold 2015. You can make a double. Double is, as you remember, is a decimal point. Double pi is 3.14, and let's say a boolean is I don't know why is Reddit cool. Let's say that it is, and you see now the variable is Reddit cool holds the value true, like this. The variable pi is 3.14, and now our year is 2015. This is just how we make how we store variables, just like in math. And one thing that I forgot, you have to terminate each statement with a semicolon. When you write an expression, something, let's say another variable, int variable is 1, you have to type this, because otherwise you'll get an error that is something like this. You'll see when you try to compile our program, you'll see that in line 7, that's right here, we get an error that a semicolon is expected after the 1. So if I type this, everything should be okay. And it is. So basic types, variables, if statements. Okay, so right now we can make the thing that I wanted to is a small converter that converts from Fahrenheit to Celsius. So for example, if we make a new variable that is, for example, double degrees Celsius, and for example, let's say that it is 10 degrees Celsius, and we want to know, we want to convert degrees Celsius to Fahrenheit. How do we do that? Well, the formula for this is pretty simple. We take the degrees Celsius, we subtract 32, and we divide by 1.8. And this should be in brackets, like this. So this is a pretty simple job for a variable. So if we say double degrees Fahrenheit is our degrees Celsius minus 32 divided by 1.8, like this. We'll get we will have degrees Fahrenheit saved in our variable. So what we do here is just subtract 32 from degrees Celsius and then divide it by 1.8. So when we have our value saved here, we can also print it out to the screen. On the print line, degrees. Okay, and also this would be a great point to show how to concatenate or how to join two strings together. We can do degrees Celsius, and we make a plus sign is make another plus sign, degrees Fahrenheit plus and make, where is the sign? Oh, there it is. Like this. This should work. Okay, now what this will do, this will look for the variable degrees Celsius, and it will put 10 here. It will say 10 degrees Celsius is, and then it will look at here. It will took the value that we calculated here, and it will substitute this, and it will write a degrees Fahrenheit here. So if we try to compile this like this, okay, it works. That's great. And we see, I get a weird character here because of this sign, so I'll probably delete it. Okay, let me compile again. Like this. Okay, so 10 degrees Celsius is, as it looks like, minus 12.2 degrees Fahrenheit. So, as you can see that the formatting is a bit strange. We get 12.2, but it suffices to just have probably this too. So how can we change that? Well, we have another method of printing out to the screen that is called system.out.printf. It's the same as print, but the F stands for formatted. So what this does, we can state the placeholders for our variables like this. If we type %d, this is a placeholder for a variable of type integer. Or yeah, but we need to hold decimal points, so I think that this is f, and we can type c is %f degrees, oh, f, like this. And what now we will do, we have to state which variables we want to change for these two placeholders. So we want to change degrees Celsius and degrees Fahrenheit, like this. I think this should also work. Yes, and if we run, okay. Now we see, what is so great about the printf method, we can change how many decimal numbers we want. For example, I can say here 0.3. For example, now this is a new placeholder, %f.3. This means that we will only print only three decimal numbers. For example, if I compile and run it again, not here, but after the percent sign, like this. Now we see that the our Fahrenheit is only 3 decimals as opposed to 6. Now we can also change here to 0.3, compile it again, like this. So 10 degrees Celsius is minus 12.2 degrees Fahrenheit. So yeah, now now for some more booleans, I will make a new document here. So why would we want a boolean type, for example, that only holds true and false? Well, they're used for evaluating if some condition is true or false. For example, I will get an ice cream if I clean my room and if I do my homework. So this is an example of Boolean expression. For example, if I this is some pseudocode. It's not It's not Java, and so if I do my homework and if I clean my room, get ice cream. This would be a Boolean expression right here. So for example, if the variable do my homework, Boolean do my homework is true, and Boolean clean my room is true, what would happen is I would get the ice cream. But if any of these conditions are false, for example here, nothing would happen because I didn't do my homework. So this is why Booleans are used to branch out and to make branches in your code. So if you want to have some logic, because most programs that aren't really simple have, we need to use if statements. So just to make it clear, in Java, this is the AND operator. So we can see here, this will return true only if the both operators, only if the both values are true, it will return true. And we also have this. These are double pipes. This is an OR operator. This will return false only when both conditions are false. So for example, true and true is true, and true and false gives us false. And if we change this, it also gives us false, and false gives us false. And for the other operator, for the OR operator, we have this. So true or true will return true. True or false will return also true. False or true will be false. And false is the only that gives false. So these are the Boolean values which we can use right now. And we also, besides this, we also have the ones that you use in math. For example, greater, greater, smaller than. This is greater or equal to, smaller or equal to, and this is equals to, for example, 5, this is true, but this will return false. And we also have a not equals. For example, 5 not equals 6, this will return true, like this. Okay, so now we can use some logic in our program. For example, I will just comment it out. The if statement. The if statement is constructed like this. We have an if, two brackets, and our curly brace. So, and we have some condition. If our condition evaluates to true, the code inside of here will execute. Otherwise, it will not. And if we want, and there's also an else statement that you have to write after the if. And if the condition here will be false, this code right here will execute. So for example, if we make a condition that is like this, if degrees Fahrenheit is larger than 100, we can write out system.out.println it is really hot out there, like this. And if it's not, we can say it is pretty chill. So right now we have 10 degrees Celsius, that is minus 12 degrees Fahrenheit. So you can know that this block of code will be executed. So if we go to our command prompt and we compile our code again, okay, okay, I misspelled degrees Fahrenheit name. So this will look like when you misspell or when you misspell a variable, it will say cannot find symbol. So I will just copy this. Yep. And it also says hello world.java, the name of your program, and colon 15. And this means in which line of your code the error has occurred. So right now I would be able to compile it, yes. And if I run it, it says it is pretty chill. So it's obvious that this code of block was executed and that this expression evaluated to false. So if I change degrees Celsius to 100 and I compile it again, we can see that it is still pretty chill. So I'll probably have to make it even hotter. Oops, I compiled it twice, and now we get it is really hot out there. So this is some basic conditioning, and we can, and another thing about ifs, we can have more than if or else. We can also have else if statements. So what an else if statement does, if the first if is not true, it does not automatically execute the else statement, but it will go and check this if statements. And so, for example, we have degrees Fahrenheit is smaller than 0. Like this, we can print out it is really cold out there. And we don't need this else. Like this. So, for example, if I type in minus 1000, like this, and I compile, we can see that it checked this, that it evaluated to false, and it went on and evaluated this, and it was really below 0. So it printed out it is really cold out there. Okay, so these are some basic building blocks. You will use if in pretty much every program you will build. So it is really great that you grab the concept of it early and evaluating true or false statements and things like that. And you can also make I'll show you how to use the AND operator in here inside an if statement. You can make an AND, so we will check if degrees Fahrenheit is more than 100 and if degrees, okay, I can't spell, degrees Fahrenheit is below 200. So we can print out like this. Degrees Fahrenheit is greater than 100 and smaller than 200, for example. And we can also check if degrees Fahrenheit is greater than 0 and if it is below 100. Let's say below equal or below 100. So we can say degrees Fahrenheit is more than 0, and it is below or equal to 100. So if we compile this now, it doesn't print anything out because degrees Fahrenheit is obviously below a 0. So we can insert an else statement. You can think of the else statement that it catches everything that these two ifs won't evaluate true to. So if this doesn't evaluate true, if this doesn't, and then this block of code will get evaluated. So make system.out.print none of the ifs were true, like this. Okay, and if we compile it really quick again, okay, I compiled it twice again. Okay, none of the ifs were true. We can see that. Now, if I change the degrees Celsius to 10 again, or no, rather 50, like this, and I compile, and you see degrees Fahrenheit is greater than 0 and below 100. So this block of code got executed. So we know what basic types are, we know what variables are, we just used a couple of if statements and booleans to insert some logic into our code. Now, now I want to showcase some basic uses for loops and maybe even methods. So I will just use a multiple line comment to comment this out, like this. Okay, and I'll save. And for example, if we have, and I'll make, let's say, three variables, and this is also important. You can't have variables with the same name. We have to every variable name has to be unique. So, for example, I say degree Celsius in USA, in Europe, and let's say in Antarctica. So let's say in Antarctica it's -50, in Europe let's say it is 10, and in USA that it is 0, because it is pretty cold. And if we wanted to convert all of these Celsius temperatures to Fahrenheit, we would have to probably do it like this. So let's say this is in USA. like this. And we have to paste it 3 times, and we change this to Europe and this to Antarctica. And we change, and I'll just copy this like this. Okay, so we can print out now, and I'll use 3 statements. Fahrenheit in USA, and I will print this one out. Well, I'll just use this one, this, and I will print these 3 variables out. Also, you can see that my variable names are pretty long, but it's better than just giving them names like A, B, or C, because then you'll get really confused and you won't know what the variables are meaning. So it's better to give them long names, and at least you understand what they're used for. So in Europe and in Antarctica, like this. And if we compile again, okay, no errors, and we print this out, we can see that in USA it is -17, in Europe it is -12, and in Antarctica it is -45. So as we see, there we have a lot of repetition in our code. We have to make 3 variables. We have to make 3 variables for our for Fahrenheit temperatures, and we have to make 3 print statements. It may be obvious, but we have to somehow to shorten this down, because, for example, if we have let's say 50 cities, it wouldn't be very nice to have 50 variables for the Celsius temperature, 50 variables for Fahrenheit temperature, and 50 print line statements to print out all the Fahrenheit temperature. So we kind of need some kind of code construct that allows us repetition and to simplify our code. These 2 constructs are loops and methods. For example, we can see here that we do 3 times the same thing. So we subtract 32 from the degree, and we divide it by 1.8. So we can package this into functions. For example, let's say if we were in math, we could say f of x is x minus 32 divided by 1.8. Like this. This is a small function, a function that takes a parameter or an argument of x, and then subtracts 32 from this x and divides it by 1.8. So I will show you how to make a method in Java. So we write public static, and again, you don't have to worry about this. Public static in or double. Now, but you already know what double is. This is, and what this signifies is the return type of our function. And this means this signifies what our method will be returning. So if we can make and we can now type the name of our method, Fahrenheit, and as we said, it will take a 1 parameter. We type double x. You see. Now this is the method body. This is the method head. So we write what the return type of our function will be. This is what we'll be returning, and inside the parens we type what arguments we want. So now we can do this double f for short, and we can make x minus 32 divided by 1.8. And now because we will be calling this method from right here, from our main method, we want to return this value. So we type return var. So how does method calling work? If I just comment this out and I do this, I just copy this, and I assign by calling the method name like this, Fahrenheit, and I give it an argument, for example, degrees Celsius in USA. Now what this will do, it will say, okay, we have a double and we call it degrees Fahrenheit in USA. Okay, we assigned to it whatever the method Fahrenheit with the argument degrees Celsius in USA will return. So the Java will then go, it will go to the method Fahrenheit with the method degrees Celsius in USA. Now degrees Celsius in USA, it will map to X. So degrees Celsius in USA is the same as X for this case. So it will go here, it will subtract X minus 32 divided by 1.8. It will store it in the variable var, and it will return this variable, which in turn will be saved here, like this. Okay, now we can do the same for our other two variables, like this, and like this. We can also call it like this. You can call a method multiple times. That's why it's so convenient. You can just you're doing the same thing basically, but you're just providing another argument. So it's much cleaner this way. It looks a lot better. So it will do the same thing. So just to check, we can type Java C. Okay. Have a problem. Okay. It doesn't find degrees Fahrenheit in Europe. Okay, we have a problem on line 26. That's here. It's complaining that it doesn't find degrees Fahrenheit in Europe. That's really weird. It says that it is already defined. Let me try to compile this again. Yep, same error. Well, debugging is also great. Is also an important part of programming. So let's see what the problem is. It says that variable degrees Fahrenheit in Europe is already defined in method main. Oh, I can see. Just what I was telling about you earlier. I didn't, as you can see, these two variables have the same name, so you can't have that. So that was my bad. It's all better now. And as you can see, it prints out the same. So this is the use for methods. Well, methods are usually probably much more complicated than that, but it shows why would you even why you would even need them and things like that. So I think that if I would go over loops right now, that it would be a bit too much. So I think it would be enough if I just gave you some an example homework just to see, just to test yourself if you really understood what I was trying to teach you today. What I want you to try to program is a really simple program. It's called, you could program a body mass index. You can Google that. What the body mass index is. It just tells you if you're overweight, if you have a normal weight, if you're probably underweight, and things like that. What you'll need to do with this program, you'll just assign, for example, an int, my body mass. Let's say that it's 80. And what you'll do, you'll find a formula, and you'll say int my body mass index, and you'll call a function, let's say BMI, that stands for body mass index, and you'll give it a parameter, my body mass. And this will return your body mass index, and then you'll have a bunch of else statements that will tell you if you have normal weight, if you're overweight, if you're normal weight, things like that. And here you will have a couple of conditions like this, and what you'll do, you'll just tell if your body mass is over 30, then you're overweight, and things like that. And inside of this, you'll have just uh, a simple print statement. Let's say system out print line, I'm skinny, like this. So this is basically it. You can search for a Wikipedia entry for this body mass index, and you can test yourself with this code. I hope that you learned something today, and that you will have fun programming, and that you liked what I was teaching you today. So this is it. I hope I'll see you next time.